Hey thinkers, welcome back to Think Sharp Alley, where every turn leads to a smart solution.
How does your phone know exactly where you are between two cell towers? It's not magic. Today I'm going to show you how to find any point on a map without ever leaving your desk. It's the section formula. Don't let the M1 and M2 scare you.
Ah, M1 and M2, they're terrifying.
By the end of this video, you will be able to split any line segment in your head, even the hot question that usually trip everyone up.
So here we are with the section formula. Let's say this is a line segment AB whose endpoints we know, and let's take a point between AB anyways, and let's consider the coordinate is x and y. Now P divides the line segment AB internally in the ratio M is to N. This is how we are going to write because that will simplify things for us. Now, how do I find out the x coordinate of P? That is given by x equal to, remember, it's always cross multiplication. So when you're finding out x, your focus should be on the x coordinate only. So m into x2 and n into x1. I hope it's clear. So in the numerator, I have m into x2 cross multiply plus n into x1 divide by the sum of the terms of the ratio. And similarly, what will be the value of y? The y coordinate is going to be m into y2 plus n into y1 divided by the sum of the ratio m plus n. Now, if P lies exactly in the middle of AB, that is, let's say like this, which means this part AP is same as BP. Over here, the ratio m is to n means AP by BP is equal to m by n. But here, since AP and BP are same because P is in the middle, so which means the ratio is going to be 1 is to 1 because the length of both the parts are same. So ratio is going to be 1 is to 1. So if you apply this section formula, you will get another special case which we call midpoint formula, which is x equal to, now you know we have to cross multiply, but if I multiply 1 into x2, it's just x2 plus 1 into x1, it's just x1 because m and n's both values are 1, right? So my formula becomes x1 plus x2 by 2 and y is going to be y1 plus y2 by 2 because 1 plus 1, sum of the terms of the ratio is 2. Now, next question comes, what kind of question can come from these two topics? First of all, of course, to find the coordinate of P. So, which we can apply in this way when the ratio will be given and we have to find the coordinates of P. And sometimes you might be asked to find the ratio. So, when we are asked to find the ratio, assume the ratio to be K is to 1 only when you are asked to find the ratio. Remember this key idea. Now let's see some questions. First question is this one, which is very basic. Let us try to draw the diagram. So we need a line segment joining the points this and this. So here we have the line segment and let us say find the coordinates of the point P. So P is this over here, which is closer to A. Why? Because the ratio is given 1 is to 3. That means AP is to PB is equal to 1 is to 3. Since 1 is less, that means P is closer to A. Okay. And I've considered this point as A and this point as B clearly. Now, how do I calculate the value of x and y? Simple. Just cross multiply. So since we are dealing with x coordinate, I'll focus on x only. So 1 into minus 3, which is minus 3. 3 into 1 plus 3 by sum of the terms, which is 1 plus 3, sum of the terms of the ratio. So in this case, it is 0. And what is the value of y? You can do it on your own now. So 1 into 9, because I'm going to see only the y coordinate right now. So 1 into 9 is 9. 3 into minus 3, which is minus 9 by sum of the terms of the ratio. Once again, 9 minus 9 is 0. 0 divide anything is 0. So which means the coordinate of the point P is the origin. So this is the required point. See how simple it is? Now, a similar question where we have to find the coordinate of the point P, but the ratio which is not given directly. Let us see one such question. Now, this is our next question. Here they have given a picture where they have clearly said and marked the end points of the line segment as A and B, and the coordinates of A and B are mentioned. And we will just write it down in the diagram as well. Find the coordinate of P. So since we have to find the coordinates of P, we'll assume it to be X and Y, such that AP is equal to 3/7 of AB. But remember, we need the ratio between AP and PB. So now we have been given AP is equal to 3/7 AB. Now this AB can come down like in the denominator. So we are getting AP by AB is basically 3/7. So very simply from here we can say let AP is equal to 3x and AB is equal to 7x. We need PB because we need this is to this length, right? So PB becomes clearly AB minus AP. That's 7x minus 3x, so which is 4x. So therefore, the ratio that we need is AP by PP, which is 3x by 4x. That's 3:4. So our ratio that we have to work with is 3:4. So let me just remove these things and write over here instead 3:4. Now that we have got the ratio, we can proceed just like we have done in question number 1. You can try it. So the value of x will be cross multiply. So when we are dealing with x, focus on only the x terms. So 3 times 2 is 6. 4 times minus 2 is minus 8. Divide by sum of the terms. 3 plus 4, 7. Which is minus 2 by 7. And coordinate of y is 3 times minus 4, which is minus 12. 4 times minus 2, that's minus 8. Divide by sum of the terms 3 plus 4, which is again 7. That's minus 20 by 7. So here the required point is, we write the x coordinate first, minus 2 by 7 and minus 20 by 7. So what is the key takeaway from this question? Remember, in section formula, we need the ratio in the form AP is to PB. If it's given differently, we must first convert it. So do pay attention to how the ratio is given before applying the formula. Okay, so till now we were finding the coordinates using a given ratio. Now let's reverse the process. Let's find the ratio when the point P is given. For example, in this third question, it is asked in what ratio. As soon as you see a ratio is asked, your first statement should be, let the ratio be k:1. Now, let us draw the diagram. We have to draw a line segment whose endpoints are this, let me name it A and B. And this point lies somewhere in between AB. So let me take it over here, P, which is 1 comma minus 7 by 2. And the ratio we have taken it to be k:1. Now, we will use section formula in the same way. So here, let us work with x coordinate. 1 is equal to yx coordinate, simply because the number is simple, 1. Rather than taking fraction minus 7 by 2, it's better that I work with x coordinate 1. But it's not mandatory, you can take any of the coordinate. So 1 is equal to, now cross multiply, don't forget the rule. So k into 2, only focus on the x coordinate. So k into 2, which is 2k, 1 into minus 2, that's minus 2 by k plus 1. So Let us cross multiply and we got a linear equation which we will solve to get the value of k from here. So k is coming to be 3, which means the ratio is 3:1. Simple, right? Now to check if we have done correctly, you may use y coordinate to calculate the value of k. But that is not mandatory. It's just for verification. So to avoid any doubt, you can use this. So minus 7 by 2 is equal to, so only the y coordinate I'll take now, k into minus 10 by 3. So that becomes minus 10k by 3 plus 1 into minus 4, that's just minus 4. So this becomes minus, divide by k plus 1. Now you can solve this. Again, you will get a linear equation definitely to get the value of k. And I believe that you will get k as 3 only. But in the exam, you can use either the x coordinate or the y coordinate to find the value of k. And once you get the ratio correctly, you can move ahead. But if you have time, you can quickly check using the other coordinate to avoid calculation mistakes. And in case you are getting different values of the ratio using x and y coordinates, that means something is wrong in the calculation. So that's a signal that you need to recheck your work. Now let us look at a slightly different type of question where the point, like over here, point P is given. So point will be given, but only one of the coordinate will be known. Like over here, we know both 1 as well as 7 by 2, like the x coordinate as well as the y coordinate, right? So we need to find not only just the ratio, but also the missing coordinate. For example, questions 4, 5 and 6. Now in question number 4, you can see we have to find the ratio. So once again, whenever the question is to find the ratio, our first statement should be let the ratio be k:1. Now in question number 4, you can see y coordinate is missing. So you can easily use the x coordinate and find the value of k. Once you get the value of k, you can use the value of k to find out the y coordinate, right? We will move on to the next question. Question number 5. For that, I need to hide question number 6. So question 6, stay hidden till we solve question 5. Now, the point lies on y-axis. Find the ratio in which y-axis divides the join of A and B. So which means the point of division P lies on y-axis. So the coordinate of point of division of P will be P 0, y, because any point on y-axis is of this form. Now since I already know the x coordinate, I can use x coordinate to calculate the ratio. So let's do that. Make sure you're focusing on only x. So 0 is equal to k into 3 and 1 into minus 4. It should be crisscross. If it's not crisscross, you're doing something wrong. So 3k minus 4 divided by k plus 1. So k plus 1 into 0 is 0. So we are getting this equal to 0. So k is equal to 4 by 3, which means our ratio is 4:3. So quickly, instead of k:1, we will write 4:3. Now, we can find out the point of intersection. We are only left to find y, right? So let's calculate y quickly. So y is going to be, use section formula, 4 into 0, which is 0, plus 3 times 7, that's 21, divide by 4 plus 3, that's 7. And 21 plus 0 is 21, and that gives me 3. So the point of intersection is 0, 3. So this is how we find out the ratio as well as the missing coordinate using section formula. Now the sixth problem is slightly of advanced type. So let me clear my screen and come back to you. This is our sixth question where we have to find out the ratio. So our first statement remains the same. Let the ratio be k is to 1 and the point of division. So previously the point of division was lying on y-axis. Now the point of division is lying on, this is a line, so it should be equation. So equal to 0 was missing. So let me put it over there. So the point is lying on this line. So I have to take the point of division to be xy. And let me fill this up. This is 3, 4. This is 7, 8. This I don't know. So x comma y, and the ratio is k is to 1. Now, obviously, I'll use section formula to calculate the value of x and y in terms of k. So x is equal to, remember, x coordinate only, 7k plus 3 by k plus 1, and y is equal to 8k plus 4 by k plus 1. Now since p lies on the line whose equation is 2x plus 3y minus 30 equal to 0, which means these two values of x and y will satisfy the line. So which means 2 into 7k plus 3 by k plus 1. So you see we have got a linear equation involving k. We solve this linear equation to get the value of k. So simply the LCM is k plus 1, which I'll multiply with each and every term, and we get 30k minus 30 equal to 0. So adding all the k terms we have 8k, adding all the constant term we have minus 12 equal to 0. So that gives me k equals to 12 by 8. So cancelling by 4 we have 3 by 2, which means the ratio is 3 is to 2. So I will clear this up and I'll write 3 is to 2 over here. And now finding the point becomes very easy, just like our first question. So just cross multiply. X is equal to 3 times 7, 21, plus 2 times 3, 6, by 3 plus 2, 5. So that is equal to 27 by 5, while y is equal to 3 times 8, 24, plus 2 times 4, 8, by 3 plus 2, 5. So 24 plus 8 is 32 by 5. So the point is 27 by 5, comma 32 by 5. So these three sums shows how flexible the section formula is in solving different types of problems. Now up next, let us look at this sum where the line segment is divided into 3 equal parts. Find the coordinates of the point of trisection of the line. The word trisection means the line has been divided into 3 equal parts, joining the points. So let's consider the two endpoints A and B. Now to trisect a line, we need 2 points P and Q. Let us consider point P to be x1, y1 and point Q to be x2, y2. Now, since it is a question of trisection, which means the line is being divided into 3 equal parts. So that means AP is to PQ is to QB is equal to 1 is to 1 is to 1. But to find the coordinate of P, I need the ratio AP is to PB. So which is equal to 1 is to this 2 parts, so is to 2. So 1 is to 2. So the ratio over here becomes, for P, 1 is to 2. By using section formula, we can find out the coordinates of P. So x1 is equal to crisscross 1 with 6, 2 with 2. So focus only on the x coordinate. So 6 times 1 is 6 plus 2 2 is 4 by 2 plus 1 3. So that gives me 10 by 3, while y1 is equal to 2 times 3, 6 plus 1 times 5 by 2 plus 1, 3. That's 11 by 3. So we have got the coordinate of P, x1, y1, 10 by 3 and 11 by 3. Now notice one thing. Q is the midpoint of PB. So you can definitely use midpoint formula to find out the value of x2, which is x1 plus 6 by 2, and to find out y2 you can use y1 plus 5 by 2, right? Sum of the x coordinate of the end point by 2 and sum of the y coordinates of the end point by 2. That is what we have learned before. Or you can go with the ratio. Now here for Q, the ratio is going to be 2 parts is to 1. So AQ is to QB. So that is 2 is to 1. So once again, opposite. So 2 times x2 is going to be 2 times 6, that's 12, plus 1 times 2 by 2 plus 1, 3. So we are getting 14 by 3. And for y2 we have 2 times 5, that's 10, plus 1 times 3, that's 3 by 3, which is 13 by 3. So that gives me the coordinate of Q as 14 by 3, comma 13 by 3. So whether you use the green method or the purple method, like midpoint formula or the section formula, your answer will be same. Another application of midpoint formula would be a sum involving circle. Now here AB is a diameter of a circle. So I have already drawn a circle, and let's name the diameter AB with the center. So let's name the center C, and that is 4, 5. So coordinate is given. A's coordinate is also given. We have to find out the B's coordinate. Now C is basically the midpoint of AB, right? Because we know the midpoint of a diameter is the center of the circle. So let us consider coordinates of B, bx, y. So let's use midpoint formula. So which says x plus 1, we add the endpoints, x coordinate of the endpoints, x plus 1 by 2 is equal to 4, and y plus 1 by 2 is equal to 5. So that gives me x is equal to 8 minus 1, that's 7, and y is equal to 10 minus 1, that's 9. So the coordinate of point B is 7, 9, and that's the answer. Very simple, right? Now let's have a look at this question. Now here we need to prove that A, B, C, D are the vertices of a parallelogram. If you have watched my video on the distance formula, you might have solved this type of question by finding the length of all the sides and diagonals using distance formula and then showing opposite sides are equal. Remember? But here we are going to use a much more efficient method using the midpoint formula. It is quicker and requires much less calculation. But we need to remember an important property. A quadrilateral is a parallelogram if its diagonals bisect each other. That means the diagonals must have the same midpoint. So what we will do is we will find out the midpoint of diagonal AC using midpoint formula, which is x1 plus x2 by 2. So here x1 is minus 2 and x2 is 4. So minus 2 plus 4 by 2 and y1 plus y2 by 3 similarly, which gives us 1 comma 1. Then we find out the midpoint of diagonal BD using midpoint formula and we get 1 comma 1 again, which means the diagonals AC and BD are bisecting each other because both the midpoints are same. So which means ABCD is a parallelogram. Now let us use the same idea to solve another important problem, which is this. Here we know the three consecutive vertices of a parallelogram ABCD and we have to find the fourth vertex D. So for that we need the diagram. So we need a parallelogram ABCD and whose diagonals AC and BD are drawn. We will consider the fourth vertex as dx comma y. Let's say, okay. Now since ABCD is a parallelogram, so its diagonals must bisect each other, which means the midpoint of AC must be equal to midpoint of BD or vice versa. Now how to find out midpoint of BD? Apply midpoint formula. So we have 1 plus x by 2 comma y by 2. And what is midpoint of AC? Again, we will use midpoint formula. So here we have 1 plus 4. Take the sum of the x coordinate by 2. And again 2 plus 0, that's 2 by 2. So now separate. So the x coordinate must be equal to the x coordinate. So 1 plus x by 2 must be equal to 5 by 2. 2 gets cancelled from both sides. So, and similarly, y by 2 will be equal to 2 by 2. Again, same process. I've cancelled the denominator 2 from both sides. So we get x as 4 and y as 2. So which means the fourth vertex is D, 4 comma 2. Now let us look at one final question. It may look a bit lengthy, but the concept involved is very simple. It's just repeated application of the midpoint formula. So here we are given the midpoints of the sides of a triangle and we have to find the coordinates of the vertices of the triangle. So let us draw the diagram first. We have a triangle with vertices ABC, but these are the midpoints. So I'm considering D as the midpoint of the side opposite to vertex A. So let's say this is D and the midpoint of AC, that is opposite to vertex B, is E and opposite to vertex C is F. Okay, so D is given to be minus 3 comma 2. Similarly, I'll write all the information. And A, B, C we will consider as x1 comma y1, B as x2 comma y2 and C as x3 comma y3. Now we will proceed one by one and you will see how same steps will repeat. Now D is the midpoint of BC. So we have x2 plus x3 by 2 is equal to minus 3, which gives me x2 plus x3 equals to minus 6. This is our first equation. Similarly, we can do for y. y2 plus y3 by 2 is equal to the y coordinate, which is 2. So that gives me y2 plus y3 as 4. This is the second equation. Now we are going to repeat the same step for for the midpoint E as well as F. E is the midpoint of AC, so x1 plus x3 by 2 equals to 1. That is x1 plus x3 equal to 2. That's equation 3. And similarly, I'll get y1 plus y3 as 2 times minus 2. So that is minus 4. And that will become equation 4. And similarly, F is the midpoint of AB. So by now you have understood x1 plus x2 will be 2 times 5, that's 10, which will be my equation number 5. And y1 plus y2 will be 2 times 6, that's 12, which is my equation 6. Now, next the key idea over here is to add all the x equations separately and y equations separately. So let me solve the x part first. So adding 1, 3 and 5 we have. Please note, here we have x1 and x1. So 2x1. We will also get 2x2, x2 plus x2 and 2x3 as well. So I can take 2 common, x1 plus x2 plus x3. So instead of writing 2x1 plus 2x2 plus 2x3, I've just taken 2 common equals to, and this side we have to add minus 6 plus 2 and 10. So which gives me only 6. 10 plus 2, 12 minus 6, 6. So that gives me x1 plus x2 plus x3 is equal to 3, and that becomes my equation number 7. Now see how we manipulate our information. So I will use 1 and 7. So 1 says x2 plus x3. So in place of x2 plus x3, I'll put minus 6. So we have x1 minus 6 equals to 3. So that gives me x1 is equal to 9. Similarly, using 3 and 7, I have x1 plus x3. So in place of x1 and x3, I'll put 2. So I have 2 plus x2 is equal to 3. So that gives me x2 is equal to 1. And finally, using 5 and 7. So 5 says x1 plus x2. So in place of x1 and x2, I'll put 10 plus x3 is equal to 3. So that gives me x3 as minus 7. Now we will use similar steps for y also. Instead of adding 2, 3 and 5 which we have done before, we'll add 2, 4 and 6. So once again we will get 2 times y1 plus y2 plus y3 is equal to add all the constant, which is 4 minus 4, that makes it 0, plus 12, so that is 12. So we get y1 plus y2 plus y3 as 6, and that becomes our equation number 8. And we are going to solve this equation 8 with each of this equation to find y1, y2, y3. Let's do that. So using 2 and 8, in 2 we have y2 plus y3. So I'll substitute in place of y2 and y3 4, and I have y1 plus 4 is equal to 6. So that gives me y1 as 6 minus 4, which is 2. Similarly, using 4 and 8 we have. So in 4 we have y1 plus y3. So in place of y1 and y3 I'll put minus 4 plus y2 is equal to 6. So that gives me y2 as 6 plus 4, 10. Now using the final one, 6 and 8. We have, in place of y1 plus y2, I'll put 12 plus y3 is equal to 6. So that gives me y3 as minus 6. So finally we have all the coordinates of the vertices of triangle ABC. So the coordinates of ABC are, or the vertices of the triangle are, so x1 comma y1, which is 9 comma 2, x2 comma y2, that's 1 comma 10, and x3 comma y3, that's minus 7 comma minus 6. So this is the whole question. Even though this question looked lengthy, it was just a repeated application of the midpoint formula. And with this, we have covered how section and midpoint formulas can be used in different types of coordinate geometry problems. In the next video, we'll take up some assertion reasoning question and case study based question from this chapter. I'll see you there. And if this video made the concepts a little clearer for you, do take a moment to support the channel. Like, share, and subscribe.